Hi, today I'm gonna show you how to calculate square roots by hand as precise as you want. We write the square root of a as some start value r plus x. We want to rearrange the formula to get the value of x without having to calculate the square root. We first square the whole thing, which gives us a equals r squared plus 2rx plus x squared. We assume that x is a small number compared to the rest, so we don't care about x squared. Subtract r squared, which gives us a minus r squared equals 2rx. Divide by 2 gives us a minus r squared over 2r equals x. So we plug that value in for x, which leaves us with the square root of a equals r plus a minus r squared over 2r. We extend that to 2r squared plus a minus r squared divided by 2r, and simplify that to r squared plus a divided by 2r. We write that as numerator n divided by denominator d. Now comes the algorithm I found. 2 times n squared minus the nominator of x squared gives us our new nominator. And 2 times d times n gives us our new denominator. Since this probably means nothing to most of you, I'm gonna follow with an example. Square root of 3 equals 2 minus some value x. I know, first I said some start value plus x, but since 3 is closer to 4, of which the square root is 2, than to 1, it's faster to use the first one. But it's perfectly fine to use 1 plus x instead of 2 minus x. It also works the same. Square the whole thing and get 3 equals 4 minus 4x. Subtract 4 to get minus 1 equals minus 4x and make everything positive. Divide by 4 and you have 1/4 equals x. Plug that in for x and we get the square root of 3 to be 7 over 4. Two times 7 squared minus the 1 we got from the x squared, which is just 1, divided by 2 times 7 times 4 gives us a new number of 97 over 56. To show you how precise this is, 97 divided by 56 is 1.7321, and the actual square root of 3 is about 1.73205. That's only an error of 0.000092 after only one iteration. The next iteration is write to 8 decimal places and the third to 18. That's more precise than most amateur calculators. Now you may be wondering how to get start value r for bigger numbers. Of course I got you covered. Let's say we have a number 54,764. Split it up in pairs of 2 from the right. Now I got 5 as my lead pair. The largest quadratic number smaller than 5 is 4, which has a square root of 2. Write 2, and for each pair you have left, add a 0. For my number the start value would be 200 then. But if you want, you can make it bigger until you have a better start value. Don't overshoot it though. What if you get something else than 1 as the numerator of x though? I'll show you with the square root of 7. Let's begin with the normal procedure. Now we get an x with something other than 1 being the numerator. Fill in for the x and continue. Now we have a reasonable approximation, but we of course want to improve. Right now it's not even accurate to 1 decimal place after the point. With the square root of 3 for example, for the numerator we would subtract 1 for every step, because 1 squared 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 is still 1. Here we will do 2 times 11 squared minus 9. The next step would be 2 times that squared minus 81, and the next step minus 81 squared. So that's basically it. If you still have questions, write a comment and I will answer it. If there are enough questions, I will make a follow-up video. Now for all my subscribers, I know this is vastly different than everything I've done before. There is so much I want to do still, but I want to go on with everything when I have enough motivation for it. There is no point in making a video half-heartedly and then being only slightly satisfied with the result. Anyway, with that said, thank you for watching and bye bye.